My name is John Mark Agosta. I'm at Microsoft. I want to acknowledge my other Microsoft colleagues who are here, especially Eric and Christian, who did most of the work here. This is work in data science that is engineering. A large part of data science is getting things to work. As Naris mentioned, the prototype took 3 to 6 months to distribute the libraries and convince the collaboration folks at the different sites to install it and get it to work. Our data science goal here is to bring that down to just days. We want applications in the cloud that collaborators, once they have the agreement, can go to the cloud, create a cloud application, and in a matter of days, commence such a distributed experiment. So, our thought here is it's a lot easier if everything runs in one place in the cloud. What we see is everybody moving their computation to the cloud by virtue of having this application. I'll explain to you what I mean by a cloud application. Here I'm speaking of an enterprise application. It's as if you take your work that you would have done locally, and with small changes, it's running on virtual hardware. You don't have to worry about what the hardware is. You don't have to worry about the scaling of it, performance. You simply need the connection to the cloud, and everything is there. And you have access to it. It's under your control. It's under security. It's under as good a probably security as you would have had locally at your own site. But it's no longer something that you have to have a physical presence for. Now, we think of the cloud, right? We think of a lot of different things. We think of what goes on in search. We think of what goes on in perhaps your distributed applications. Perhaps you've got your office suite in the cloud. Your view of the cloud is what we call a tenancy. It's a tenant. You only see the piece that's yours. It's not apparent to you that anybody else is there at all. And this is where the security aspect comes in. Now, this raises a challenge. This raised the challenge to us, so we understand this well. Take an enterprise application, move it to the cloud. We have models for this. We have architectures for this. This work with Stanford raised an interesting question. We want collaboration across tenancy. We want these secure bastions of computation to be able to talk to each other and communicate in real time. And that's the problem we had to solve here, and that was novel. How do we do this? Well, what we think of here is each of these cloud applications, here shown as these globes, communicate with other applications to form this network. You've seen this picture before. Here I've just rewritten it in terms of these applications. Each of them would be identical in terms of creation, but then they would be instantiated and customized with the knowledge of who they communicate to, how they're authenticated locally. And in this case, I've shown how the data is applied. Everybody would have local data, either in case of worker 2, it's actually contained within the application itself. In the case of worker 1, there's a SQL database, could be on-premise, it could be in the cloud that contains their data. In worker 3, I've actually got a little data lake there, perhaps a very extensive set of data that's sitting up there in the cloud. The point is that nobody sees anybody else's data. No one sees anything but the communication that runs along the wire that is possibly encrypted, and certainly a simple statistical summary of the data that is available at each site. So this is a set of peer-to-peer applications, and to set this up, a user needs the credentials, of course, to set up their own tenancy, and they need a secret to identify who they talk to. So what is a cloud application? I wanted to give you a picture of what this actually consists of. It's a whole bunch of resources. These are all created automatically when you create the application. This is the work that we're doing, is to figure out how to do this. But I've labeled these in terms of what they do. We've got storage here marked in yellow. We've got a bunch of storage accounts. We've got a bunch of machines marked in green. We've got a bunch of network resources. And in red, I've got the little thing, which is the key vault, which contains the secrets, which provides access to the things that provide security. This is from a screenshot of what you go to when you see your applications in the cloud. How do we see this working? Well, you'd install this app locally. That's the first box. Then there'd be some coming together. We call this the lunch. Imagine here at lunch, everyone who is interested in a collaboration get together and decide they want to run a particular model. Once they've agreed on the model, which is something that Naris showed as part of the software step, they could go off back to their local application, load their data, and test the model, and just run a local version of it. Once we've got that, the master could push a button and run this distributed algorithm, and it would be basically hands-off for the participants, generates a shared model. Everybody then receives a copy of the model, which would be equivalent as if the data had been pooled. But we've done this without having to bring people's data into one place. We get the same result in terms of the statistical result that produces the model among the participants as if they had all decided to go through the rather current tedious process of anonymizing data and bringing it into one place. So this now automates that task. And then we could imagine going back and repeating this as many times as you want to produce perhaps other models with the same infrastructure. So how do we put credentials together? Let me go through this quickly. Each tenancy has the ability to generate a set of tokens. In the application, the tokens are then used. They are good for a particular set of roles and a particular time duration, and they become then part of the RESTful request that is exchanged between sites that authenticate them to sites. Now, this is a little bit of a challenge when you have multiple applications in different tenancies, because now you need to be able to go from tenant to tenant. So how do you do this? You actually have at the Azure level an ID broker that talks to the authentication resource, this Active Directory at each tenant, shares this token, and then this token gets used between sites. So this then gets done symmetrically between sites to generate tokens that work both ways. So where do we go with this? As I say, you know, it was extremely flattering to have Stanford Data Initiative come and say, this is an interesting project, and to come and basically give us a forum and also resources to pursue this. So our goal here is to bring this from something that is an interesting research concept into something that can be used and distributed and basically is now shareable simply by having the ability to spin up an application in the cloud and participate with this software that would install and run with a limited amount of actual user participation. Now, we see this as not only useful in this particular set of Cox algorithms and clinical realm, we see this as a framework. For us, this is valuable as a framework that applies widely, and it kind of opened our eyes to a new set of applications. What we have to do now is, as you see, this flow diagram involves a few steps beyond simply running an algorithm. We have to think about how we make this into a workflow. We now see this as a reusable architecture that we can apply widely, not only within this realm, but within other areas of the cloud. So overall, what we've done here is a bunch of engineering. Stanford gains an industrial strength platform on which to build ideas such as this, and Microsoft benefits by being exposed to a new set of problems. We now have a new set of architectural designs on the shelf, and we've actually gone from sitting behind our desks to actually looking at things that opened our eyes to some real needs in computational models. Thank you.